In this section, we're going to examine the rectangular coordinate system, also referred to as the Cartesian coordinate system, and we're going to learn how to plot some points. Now, the reason it's called the Cartesian coordinate system is because the whole system was developed by a French mathematician named Descartes. The reason why he developed the system was he was looking for a way to tie together geometry with algebra. So this is how he did it. Let's look over here at a rectangular coordinate system. It's made up of a vertical line, which we call the y-axis, so put a y by it, and it's also made up of a horizontal axis, which we'll call the x-axis. Now notice both the x and y-axis intersect at a point right here, which we'll call the origin. So this point here is referred to as the origin. Or in other words, that means the place of beginnings. This origin is where we begin when we plot lines or points in the coordinate system. Now notice something else, that the x and y-axis here, they divide the plane that it lies in into 4 different regions. These 4 regions we'll refer to as quadrants. Now the quadrants are numbered in a counterclockwise fashion. To the top right here, this is called quadrant number 1. To the left of quadrant 1, we find quadrant 2. Right below, this is referred to as quadrant number 3. And finally, bottom right, we call this quadrant 4. Now notice I use Roman numerals to depict each of these quadrants. And the reason is that's just standard notation when referring to the coordinate system. So now that we know a little bit about our coordinate system, let's begin to plot some basic points. Let's look right above here. And what we're going to do is plot the following points. Up here, we're going to plot the point B with the x coordinate 3 and the y coordinate 4. Now again, when an ordered pair, and this again is called an ordered pair, is given, it's given in the order x comma y. Now the reason it's called an ordered pair is because order matters. Whenever you look at an ordered pair, you can always assume that the first entry is the value of the x, and the second entry is always the value of the y. It'll never be given as y comma x, always x comma y. And that's our ordered pair. So in the first problem here, where we're going to plot the point 3 comma 4, what that means is this. We start right here at the origin, the place of beginnings, and since our x coordinate is 3, what that means is the following. First of all, let's decide which way do we have positive numbers. Well, along the x-axis, starting at the origin, if we move towards the right, these numbers are positive. Starting at the origin again, along the x-axis, when we go to the left of the origin, our numbers are negative. So we have -1 up through -4. Now similarly, if we start at the origin and we're going to label numbers along the y-axis, when we go above the origin, those numbers are positive. So here we go, 1, 2, 3, and 4. And down below the origin, along the y-axis, that's when the numbers take on a negative value. So we have -1, -2, -3, and finally -4 down there. Now that we have our axis labeled, we can then go ahead and finally begin to plot that point B with coordinates 3 comma 4. So again, starting at the x-axis, at the origin, we're going to go 3 units to the right because we want to go a positive 3. So that puts us right here. Now, since the y coordinate is 4 and that's also positive, we're going to move in the positive direction on the y-axis, which in this case is up. So over 3, up 4, 1, 2, 3, 4. We put a little dot there. And that's the graph of the point B with coordinates 3 comma 4. Again, the key to graphing points is to start at the origin. The first value is the x value. It tells you which way to go on the x-axis. If it's positive, we go to the right. In this case, we went over 3. The y value was positive, and it's 4, so we move up 4, and there's the graph of our first point. Let's try a second point. Let's this time graph I at -2, -4. -2, -4 again. We start here at the origin, 0, 0. and we're going to go to the negative, in the negative direction along the x-axis, which is 1, 2, and then in the negative direction on the y-axis, which is going down, 4. 1, 2, 3, 4. So here we have this point here. We'll call it I. That's the graph of -2, -4. Finally, let's try another one. Let's do, J is -2, -4 as well. Well, since we did that one already, let's change that to +2, -4. So let's graph J at +2, -4. Starting at the origin, we're going to go over in the positive direction along the x-axis, that's 2 to the right, and then again, 4 down in the negative direction. That gives me J. Finally, I have one last point to graph, and that is K at 4, -2. So what does that mean? We go over 4, 1, 2, 3, 4, and then down -2, 1, 2. So there's finally our last point, K. Now, just as a review here, can you name the quadrant that does not have a point graphed in it? Can you name the quadrant that does not have a point graphed in it? Do you remember how we numbered our quadrants? 1, 2. Quadrant 2 didn't get a point graphed in it, and the reason is to be in quadrant number 2, you'd have to have the negative x value and some positive y value at the same time. Practice plotting these points. It'll be a lot of fun. Now that we looked at our first graph here, what we're going to do is kind of go the opposite way. We're going to kind of play like Jeopardy. We're going to look here at this coordinate system, and again, we've got the x-axis going horizontally and the y-axis going vertically. What we're going to do in this case, instead of plotting the points, notice the points have all been plotted for us. Our job in this one is going to be to give the coordinates of each one of these graphed letters. So let's start with the letter A. Let's find the coordinates of A, and remember, most importantly, an ordered pair lists the x value first and the y value second. So let's look at A here. Again, starting at 0, 0, we're going to go in the direction of -2, 1, 2, and notice we're going down, so that's also a negative, so it's -2 and -1. So A has coordinates -2, -1. Are you ready to try another one? Basically, it's just kind of counting here and remembering which directions are positive and which directions are negative. So let's look at B. To get to B, we start again at the origin, and we're going to do our x direction first. In this case, notice it goes over 1 to the left, so that's -1, and then 1, 2, 3, and notice that's positive this time, so here we get -1 for x and +3 for B. So we finally get that point in that second quadrant there. Notice it's negative, positive. Now, finally, we're going to give the coordinates of C, which is at the origin. So C here, notice we don't move in the x direction at all, we don't move in the y direction at all. So since we're not moving off that origin, C has the coordinate 0, 0. Let's move on to D. D here, notice, is to the right of the origin along the x-axis, to the right 1, 2, and notice we go down 1 along the y direction, so that would be +2 for our x and -1 for our y. Finally, we have one last one to do, and that is E. Notice again, it's to the positive direction on the x-axis, 1, 2, 3, 4 to the right, and up positive along the y-axis as well. So we said 4 to the right, and 1 up makes it a +1. So just all we're doing when we're getting the coordinates for these points here is basically we're just counting to see which direction, and noticing which direction we're moving, if it's to the positive direction or to the negative direction. Now that we've learned how to plot some points, let's look at some linear equations and see how all this ties together. Now what we're going to do here is we're going to look at the following equation. 3x minus 4y equals 12. Now this is a linear equation in two variables, x and y. Let's say, for instance, now we're going to learn this in the next couple of sections. When we graph this equation, it's going to turn out to be a line. That's why we call it a linear equation. But let's say we want to find some ordered pairs that lie on this line. The reason why we do is because once we find some ordered pairs, that's going to help us graph this line. So let's go ahead and start. Let's say we have 0, comma, and we want to know what y-coordinate goes in this ordered pair if we know the x-coordinate is equal to 0. That's pretty easy to do. Since x is equal to 0, we're going to take the value 0 and substitute it into the equation and let x equal 0. It looks like this. 3 times, now we're rewriting that equation, 3 times 0 minus 4y is equal to 12. Now once we do this here, notice our equation is solved for y because all we have, our x is gone and we just have an equation in terms of y. So the rest of it's just use our algebra that you should be good at by now in solving this equation for y. When I do, 3 times 0 is 0, minus 4y is equal to 12. Now 0 minus 4y, simply negative 4y. That's equal to 12. Finally, to solve for y, all we have to do is divide both sides of our equation by negative 4. When we do on the left-hand side, negative 4 divided by negative 4 is 0. 12 divided by negative 4 is negative 3. So what does this mean, y equals negative 3? Well, what it means is if we take x equals 0, substitute it into that original equation there, we get y equals negative 3, which means that this point, 0, negative 3, is a point that would lie on the graph of this line, 3x minus 4y equals 12. Now, just for practice, let's find one more point that lies on this line. Let's look at something, comma, 3. So in this case, we know the y value, but we do not know the x value. So using the method that we just used in the first example, we're going to let y equals 3 into this original equation and solve it for x. So this gives me 3x minus 4. In place of y, we're putting 3, and that's all equal to 12. Once we do that, we get 3x minus 12 equals 12. To solve this equation for x, we're going to add 12 to both sides. 3x is equal to, on the right-hand side, when I add 12, I get 12 plus 12, which is 24. Finally, to solve this equation for x, I'm going to divide both sides of my equation by the number 3. When I do, I get x is equal to 24 divided by 3 is 8. Now, what does this mean? It means that if I take the 8, it's going to go into my ordered pair here, and it's going to give me 8, comma 3. Now, what does this mean? It means that the ordered pair 8, comma 3 also satisfies this equation, which means it also lies on the graph of its line. So far we have 0, negative 3 as a point on this line, and 8, comma 3 as a point on that same line. Once we find many points, we'll actually be able to graph the line. In the next section, that's what we're going to work on. That's graphing the lines instead of just plotting our points.